Right. Um, Before we get started, my understanding is that the kind of quiz thing that people are getting stuck on a question because there's a bottleneck, which is James Lewis. People have to go and ask James Lewis a question. What's the question? Do people? What's the question? So what? Something about World of Warcraft. James, do you want to put people out of their misery if they're still stuck on that? How many people are stuck on that one, or how many? Okay, no, it's not. A couple of hands go up. People are embarrassed to admit it.
I've got one. So, for the avoidance of doubt, my faction in World of Warcraft, after 20 years of playing the game, is the Horde. Horde. Horde.
All right. Thanks for clearing that up. Right. So just to kind of a little bit. So as was mentioned, I've been with Thoughtworks now about 15 years. And my role now is distinguished engineer, which is nicely a little bit vague. But essentially, how I would define it is I get the opportunity to kind of talk with different people inside and outside of Thoughtworks, with our clients, with teams, and share information. Right? I learn things and I share things and I encourage other people to share things and all that. So it's really quite a cool role to have. And so that's part of what I'm doing now is kind of sharing some of the kind of thoughts and observations that I've kind of come to from talking with various teams and challenges that they had in various clients. So one of the things a really big thing is that when we had cloud, so cloud kind of came out a bit more than 15 years ago, before I joined Thoughtworks, actually, but before 2010 was when cloud started to kind of emerge, and we were starting to use it for things. And it was great. It was gonna, it was the future. It was gonna do a lot of things for us. Then infrastructure as code kind of came with it, which was goes nicely with it. And the things that what it was going to help us to do was that because we had cloud, we can provision infrastructure on demand, right? So before we had this, I guess I should kind of like lay the background was like it was really we used to use physical servers, right? And when we had to provision a new server, say, we would have to order it and get some hardware and assemble it and bring it down to the data center and put it in the rack and so on and so on. And there's quite a lot to it, right? But with cloud, we can have it on demand, right? We can click a button. We can use an API, run a command, or even with infrastructure as code, we just write some code and it just kind of the infrastructure will appear when it's needed, and we don't even have to kind of be involved moment by moment. And then because we're using this code to define our infrastructure, all of our environments and everything will be consistent and reliable. So we won't have this kind of thing of like, well, we deploy it in one environment and then it doesn't work in the next environment and so on. Works on my machine, doesn't work here, whatever. So this was the promise, right? But one of the things we see is the reality is not quite there in terms of how we're experiencing it. So what a lot of folks tend to find is that like deploying can take too long. Deploying to an environment, whether it's a build, whether it's to production, or whether it's a test environment, development environment, we often have a lot of obstacles before we can do that, or deployments fail and need special attention and all that. It's just like, it wasn't kind of supposed to be like this. Another thing we have is that we don't have enough environments. And on the flip side, we're spending too much money on environments, right? So we're bottlenecked on like, we have multiple teams who need to deploy their builds. The environment's not ready, or another team's using it, or somebody else has messed it up, or what have you. And so like we have this thing of like, maybe we should, create some more environments. But then we end up spending too much money on environments and infrastructure. And so these both things tend to be true. I'll go a little bit more into that later on. And then as far as like people who work with infrastructure, we spend too much of our time dealing with that stuff, right? We spend too much of our time fixing deployments that go wrong and fiddling with the infrastructure and just dealing with these kind of things, and not enough time to improve and update. So one of the things I find when I go into a client and I'm hanging out with the infrastructure team is it's like quite often they know what they could be doing, right? So it's not that I'm coming in and telling them, hey, let me tell you about this new kind of thing in infrastructure as code. It's like, no, they know about that. Just we don't have time because we're fighting fires all the time. So what it should be like really is software teams, and when I talk about software teams, I mean everybody involved, not just developers, but like testers and product managers, delivery managers, everybody who's involved in, um, building software and getting it into users' hands. Ideally, they would be in control of the infrastructure. What infrastructure do I need for my application? Um, and like for if I'm a support person, I should have access to it. I should be able to kind of deal with my infrastructure, right, and have it as I need it. um, that's not to say that there's not a reason to have the people who are specialists in this stuff, but those of us who are kind of specializing in infrastructure should be spending our time and energy and kind of making sure that those software teams have the infrastructure that they need and have the kind of the stuff that they need to help them to succeed with that without kind of over getting in their way, basically. So I think a lot of what this comes down to is there's this disconnect between, say, the business at the one end and infrastructure in the end, and all this kind of stuff in between. And I think we're often too invested in this idea that, well, infrastructure is just like plumbing. It's not like, it shouldn't really matter too much, right? It should just kind of be undistinguished stuff. So the cloud vendors have done a really good job of taking the stuff that really is undifferentiated in terms of what we need to build and run our software and putting it behind an API. There's actually a lot of stuff in between in terms of, this is why things like DevOps and SRE and platform engineering and all these things keep coming up, which are kind of reiterating a lot of the same things of like, there's stuff between just, I'm writing application code and I need to be able to run it. The cloud by itself isn't enough. There's a lot to kind of do in there. And there's a lot of pitfalls we fall into, and we don't kind of appreciate the alignment and respect to that we need to really think about what we need to do with the infrastructure to support and really enable the software delivery and the what we're doing on that end. So the kind of approach that I think we often take by default with infrastructure, and this goes back to the days when it was physical hardware, was we kind of do a bottom-up approach, right? So if we have a given environment, we go and we deploy the infrastructure into it. We set up the infrastructure, we configure it. That might be a separate team, but even when you have a software team which owns its own infrastructure, oftentimes they still take this approach of, first we lay down the environment and set it all up. So even like the cloud vendors, you have like the landing zones concept, which is very much like there's this generic bit of infrastructure that we lay out for any client. It's always the same, more or less. And that's all we have to, and that's all there is to the infrastructure, right? We'll put that in place, then we'll leave, and then, it's your problem to get your software to work on it. Right now, I still to this day do hear infrastructure people saying, the infrastructure works, right? We deployed it, it's all configured, it all works. If your application doesn't work on it, it's an application problem. It's not something we need to think about, right? And this is why those problems I mentioned earlier. Why are we not seeing those benefits of the cloud and infrastructure as code? It's because we still often fall into this mentality of, well, these things are just disconnected, and we shouldn't kind of have to think about how they interrelate. So before I get into like the alternative to that kind of bottom-up approach, I'm going to talk a fair bit about ways of measuring the effectiveness of kind of infrastructure management, whatever you want to call it. And the place where I start with that is looking at the software delivery effectiveness, right? So what just happened there? Oop. Okay. Oh, pop ahead a bit here. Yeah. Okay. Sorry. All right, you got to go out of sync. Yes. Okay. Yeah, thank you. Yeah, I get so excited. Sorry about that. I will try to kind of slow my pace a bit. So the purpose of infrastructure, especially when we come to that thing of thinking about the path to production of the test environments, development environments, and all of these kind of things, is to enable software delivery. So the place to start when looking at how good of a job are we doing or where can we improve is to start with the software delivery part and what's effective there. And I think there's fairly well-established metrics. So there's the DORA 4 key metrics that get talked about a lot. The fact that you're here probably means you're familiar with Thoughtworks. If you're familiar with Thoughtworks, you're probably familiar with the DORA key metrics. But release frequency, delivery time, recovery time, and delivery failures. So the first place I always tend to start is, well, how are we doing on these things? Where are the things that maybe need some time and attention to improve on? Then when it comes to the infrastructure and all of that, I think we can also, there's some other useful things we can think about in measuring how well we're doing. So things like cost, people focus a lot on, we hear about FinOps, so we talk about cloud costs and hosting costs and all of that. And I think that's important, but one of the things I worry about, there's a little bit of a side rant here, is that it's easy to measure, right? Because it's, you have APIs and stuff and you get bills, and so you can measure the cost. I think it's really important to also think about the value. So like when I have somebody say, well, we're spending, 5 million, euros a month on our infrastructure, on our cloud infrastructure, somebody else saying, oh, we're spending 50,000. I don't know whether that's good or bad in each case. The 50,000 one might be way too much considering what they're using it for. The 5 million might be, a steal if they're, generating gobs and gobs of revenue off of it. So you really need to think about what's the value you're getting out of your infrastructure. And so that's one part of it. And then I think it's useful to look at the utilization as a kind of a counterbalance there. So if you can measure how often your infrastructure resources are sitting idle, that's going to tell you a lot about, are you actually, getting it's not necessarily the same as the value, but it's like if you have those environments sitting around for a lot of the time, then that's where it's useful to kind of think about, well, how do we reduce that rather than necessarily playing with which particular, I don't know, instance sizes you're using. So I think that's just an important general thing with all of this. Also, when it comes to your infrastructure and around the delivery of the kind of path to production, how much effort is involved in a release, especially from say your infrastructure experts, people who know this? Do you actually have to have special people embedded in your teams, DevOps engineers in every team? That's to me is a sign that that's a high level of effort that you're having to spend on this. There's obviously the things in terms of the system that you're hosting and how well you're doing there. Are you meeting the capacity needs? Are you aligning the capacity needs, the performance and availability? So I'll go a little bit more now into the infrastructure part of the software delivery and infrastructure capabilities. So there's three kind of key capabilities that are often useful to look at. So the capability of provisioning an environment to deploy a build is a key one, and that's the one I'm going to focus on today. You can also look at, it's also useful to look at, you're delivering a change to your infrastructure. How effective are you at doing that, and measure, you can measure that. And then ensuring consistency across environments. So how often do you have problems where you get software working in one environment, but then when you deploy it to the next, you need to do extra things to get it to work. And these are often in contention. So what tends to happen is, okay, we use it, we use infrastructure as code to define our systems and all, and that's great. And then over time, we need to make changes to it. We need to make tweaks to it. And that's where things start to get inconsistent. So that's quite a tricky thing to do. But I'm going to focus today on provisioning an environment. And the reason for that is because it's a major part of your overall flow. So if you're looking at all of those issues of how often can we get releases out, how long does it take, how often does it fail, and so on, we're deploying to an environment multiple times, and often for each environment, like a development environment or a testing environment, we may have multiple times where we're deploying builds into that before we get it into production. So this is one of those things where if we, this is typically a big pain point and typically one of the reasons why we might not be doing as well on the overall metrics as we like. So specifically for that capability, what is good to measure? So I can kind of build on those DORA metrics, right? But more on the micro level of, so let's say whether it's a development environment, I'm a developer, I'm working on code change, I want to deploy it to a cloud instance to test it before I kind of push it into main and all. How long does it take? Or an automated testing stage in a pipeline, or a manual testing where you're going to do exploratory testing. What is the time from a build is available from the previous stage and now ready to be deployed, and it's actually deployed and ready for use, it's working correctly? So you can kind of make a metric out of that and see what's involved. And if that's too long, what's involved in that, right? Also the failure rate of, so for the DORA metrics, when we talk about the failure rate, we tend to be talking about in production. So for the release in the end, how often does something go wrong and somebody needs to intervene, mess around with it, redeploy it, or what have you. And so for each environment, you can also look at that. Well, how often do we need to mess with that? And so we think about, well, what are the challenges that make those kind of metrics, not where we would like them to be? As I mentioned earlier, so there's that case where you have not enough environments, and so builds queue up, waiting to go and be deployed. Um, so one solution to that, a common one, is, well, we'll just share the environments. We won't make people wait, right? Everybody can just deploy their stuff into the QA environment, the development environment, whatever. And then also that saves on costs, right? We don't have to give every team their own environment. And then you get a lot of failures, right? Because people are stepping on each other. And I've seen people spend like a day or two trying to figure out, well, what's wrong with our builds? We made some code changes, we deployed it, it's not working, what's wrong with it? Oh, another team went and messed around and broke something else in the environment, and we didn't realize, right? So the other thing is, well, maybe we can have multiple deployment environments, give every team their own environment, maybe multiple environments, give every tester their own environments. But we end up with, obviously, that's higher hosting costs, increased maintenance, so like more environments to manage and mess around with. And that it tends to reflect in utilization. So what happens with this is you get that complaint of, we don't have enough environments during the peak times before a release. Everybody's working to get things tested and going. And then in other times, the environments are sitting there. And this is usually because it's too much effort. It's a lot of effort to create a new environment. And so again, it's that kind of long creation time or long time to having the build ready. And so we leave it, right? We ask, we have an environment, it gets, we manage to get it created. A week, 2 weeks later, the environment's all set up for us. And then we don't want to let it go, right? So we leave it sitting there, racking up costs. So the other kind of challenges like the manual effort involved. And so the thing here is that even with automation, even all of these things that I've been talking about, I'm not assuming that you're not using infrastructure as code. So it's one of the things when I wrote the first edition of the book, and I was doing these kind of talks, and I had somebody ask me, well, what are you going to do once everything's in the cloud and everybody's using infrastructure as code? There's not going to be anything to do anymore. And it's like, yeah, there will be. Because everybody's using infrastructure as code to some degree, but we're still having these problems and it does come down to those making changes to your infrastructure, and how do you do that effectively? How do you do that well? So I'm going to come to the application-driven infrastructure, right? So the idea here is, if you remember, I was talking about the bottom-up approach, which is kind of our typical default way to think about deploying infrastructure. The application-driven approach, and this is one of these things where there are various vendors and tools out there that are kind of going in this direction, but it's a little bit woolly right now. It's a little bit, it's not, I would say, the default. And it does take a bit of effort to kind of set this stuff up and do it. But the idea here is that as a part of the application delivery process, as it reaches each stage, that's when you deploy your infrastructure, right? So you have your application artifact, whatever that may be, a container these days usually, and you have some way of specifying, well, what infrastructure does this application need? Do I need a database instance? Do I need a message queue? Do I need connection from public internet to inbound connections, or those kind of things? So you have some kind of a specification of specify the infrastructure that goes along with the application, and that determines the infrastructure that gets deployed. And so the idea here is that you may well have like an orchestrator, and so this can be something along the lines of a GitOps type server. There's a number of infrastructure kind of deployment services that are out there these days, and I have a link at the end where I have a resource where I kind of list a bunch of kind of interesting tools around this space. But the idea is that it's not necessarily that when I say that there's an infrastructure specification that goes along with the application, I don't necessarily mean that your developers are having to write all the infrastructure code themselves, or not necessarily as a part of this. Ideally what you have is we have a more componentized approach to infrastructure. So we're using infrastructure as code. We're building that to make components that a specification can then say, I need a database. And so our component is a nicely built, a bit of code that says, here's how to build a database properly for our organization with our kind of policies and constraints and good practices around that. And so a lot of the focus of infrastructure engineering comes into that building of components. So if we saw Oscar's talk earlier where he was talking about things like using policy as code and so on to manage, as you're building infrastructure as code to make sure that it's correct and everything. That kind of stuff can happen in a pipeline for the infrastructure component. And then that can go into repository versions, just like any software component. And then that's what can be referred to when you're deploying your application. So in order for that to work, we need to make our infrastructure more composable. And so what I mean by that is, well, a typical way to build infrastructure with code is to have a big infrastructure project, which has everything in it for all of your applications that run on it. So I've seen at one client we had in London, they had a Terraform project that when you ran Terraform apply, it could take up to 2 hours to run. They had a file called rds.tf, which is for databases. It had 60 MySQL instances defined in it. So they really did that bottom up. We've got our infrastructure code to build out all of our infrastructure in one big go, and then we deploy the applications into it. So clearly we want to do the similar thing that we do with software, that we're doing with like data, where we say, let's break it up into separately deployable components. This isn't just for those who are familiar with Terraform. People often say, oh, we'll use Terraform modules. Well, Terraform modules aren't inherently a deployable component. So you have to go a little bit further and say, how can we make sure that each of these things, whether it's the applications for, the infrastructure specific to one application, can we kind of define that into a separate project, a separately deployable project? Can we test that on its own without having to deploy everything else in the world in order to run the tests? And so with more complex environments, you get into situations where you have, say, infrastructure stacks for each application, which say what goes in that, and that might be using, again, these are pulling, infrastructure components that have been built and defined, things that come along with the environments of shared infrastructure resources and so on. And then, you have your applications being deployed. So there are pipelines for each application or each service or whatever it is the way that you deliver software in, deploys to a given environment, and again, makes sure that the infrastructure for that application is deployed and pulls the right stuff there. So you might have then like a platform service deployments. So platform services to me are really not any different from applications in the sense that you're going to write some kind of a code that defines them, and you're going to push them through pipelines, and then you might deploy them into environments where there are more kind of static environments like production, and maybe staging environments might be like that. But you can also do some really cool things. So we can have on-demand or just enough environments, so ephemeral environments and so on. So the idea that for my application, for my service, we're going to have a pipeline stage where we want to test just our application. We don't want to have to deploy the world in order to test our service or our application. And so because we're using this kind of more composable approach, we can say, right, in order to run these tests and deploy my application, I need my application's infrastructure. I need this shared service, but maybe I don't need this stuff, right? And so then you can have a much smaller environment, and that becomes more tractable with things like when you're doing like an ephemeral environment where you're going to spin up the environment in order to run the tests, and then tear it down again. Like that's quicker because you don't need to, again, deploy the world. So that's the kind of rough idea. There's a couple of challenges. What do we have to do to make this work? So one is, as I said, it's that architecture, right? How do we define infrastructure components? And again, this is an area that's not very well established in the industry from the tool vendors. So it's interesting to me. So the most kind of common component we have with infrastructure is the module of Terraform, which is kind of like a library, right? And they have versioning and they have like a registry, so you can use an artificial, just like any software. That's kind of nice. But when it comes to, well, what's the thing that I deploy for my infrastructure? That's just a project, and they don't even have Terraform. They don't even have a name for that unit. It's a project, but it's also like maybe it's a workspace, maybe it's a state file. These are all things that kind of correlate to it, but it's not a concept. There's not a version thing. You can't tell what version of our infrastructure, of our Terraform project, say, have we got deployed? And most of the other tool vendors aren't really much better. Probably the closest is Pulumi, because they're built on a much more of a software kind of paradigm for their tooling, so you can do a little bit better with that. But this is something that, but again, so a lot of the tooling around, particularly Terraform, which is the kind of one of the most, or the biggest mind share, the biggest, what kind of drives a lot of the thinking around how to do infrastructure as code. Most of this stuff comes from other tools. So if you use things like TerraGrunt or TerraTeam, or there's all these kind of what they call tacos, Terraform automation, something servers. It's just basically, it's all these third-party software that people have built in order to kind of try to manage this, to try to create a decent component architecture and kind of deployment deployment regime. And so this is an area that's quite, I guess, underdeveloped at the moment. And so again, that link that's that I've got there, I've kind of list a bunch of interesting tools around this area that you can explore if you want to implement this kind of thing. And then there's the delivery part of it. So if you have a component, well, how do you deliver it? How do you do pipelines? How do you do testing? How do you do things like enforcing policies and so on? How do you know what it's going to cost? Can you, if you've got these components, you're building your infrastructure that way, can you do something where you can then say, well, I know how much it's going to cost then to run this, right? And so I can do some more accurate projections of what we're going to spend on our environments. So that's another big thing. And then finally, that deployment orchestration piece. So how do we manage that thing of, as an application developer, how do I specify what infrastructure my application needs? What has to happen, in order to make that get deployed, and for the infrastructure to be deployed, and all of that. So again, that link, there's various tools which kind of approach different angles of that. So it's a really interesting space to explore. And that's pretty much what I've got. I'm happy to take questions about this stuff or related stuff or other things. Ask me anything.